Hello, 30-1s. In this lesson, we're starting our new unit in trigonometry. This unit's all about identities. What the heck is an identity? Well, an identity is essentially, it's an equation that is true for all permissible values on both sides of an equation. So what does that mean exactly? Well, before we start thinking about trig, maybe let's think about something that we already know. Let's think of an equation. Well, we could say this: a squared plus b squared is equal to c squared. That's an identity. I know that the left-hand side is equal to the right-hand side. Okay, so this is a very basic type of identity. It's not at all what we're going to look at in this unit. We're going to start turning it into trig. Okay, well, since we've already got one of the most famous formulas of all time written down, let's continue with it. Let's think of the unit circle. The equation of the unit circle comes from the same formula, doesn't it, right? It's just Pythagorean, just with a unit circle with a hypotenuse of 1. All right, we're slowly turning into trig. Now let's think of what we know off our unit circle. Off our unit circle, we know any point on our unit circle can be written like this. Well, let's adapt what we have here then. Cos squared plus sine squared is equal to 1 because cos is x and sine is y. Now, I'm just going to rearrange this because this is how it seems to be written on most formula sheets. Sine squared plus cos squared is equal to 1. Here is the first trig identity that we will work with in this unit. So we're going to play around with this thing, and it's going to become almost like a puzzle. You're going to learn how to change this form and turn other things into looking like this. So it's a bit of a puzzle. You'll see what I mean in the next example. So we just developed our first basic trigonometric identity. It's an interesting one. Sine squared plus cos squared equals 1. It looks very brand new. But like I was saying, we can turn this into different things. That's going to be the whole point of identities. How can we change these little puzzles? Well, even though there's really, it looks like one thing here, well, we know we can rearrange this. Look at, we can rearrange to get sine squared by itself. There's another identity. We can rearrange to get cos squared by itself. There's another identity. So even though we only have this identity on our formula sheet, from that one identity, we can quickly find 2 more identities. Cool. Okay, now let's play around with this basic identity. Sine squared plus cos squared equals 1, a little bit more. Well, we know we've also got, in our primary trig ratios, we've also got tangent. Well, how do we get tangent out of this? I only see sines and cosines. Well, what I know is tangent theta is sine theta over cos theta, right? It's y over x. So let's do that. Let's get that in here. Let's divide everything by cos squared theta. Now I'm allowed to do that because I'm changing how it looks, not what it's equal to. Guess what? Sine squared divided by cos squared, tangent squared theta. Cos squared divided by cos squared, 1. Don't say cancel. 1 divided by cos squared, secant squared theta. And there's a brand new trigonometric identity. So you're starting to see how we're going to play around with these things to create new identities. Let's try it again. Instead of dividing by cos squared, what would happen if we divided by sine squared? I don't know. Let's find out. Again, I can do this because I'm changing how it looks, not what it's equal to. Well, sine squared divided by sine squared is 1. Cosine squared over sine squared, well, hey, we know that's actually cotangent. So cotangent squared. 1 over sine squared, cosecant squared. Check it out. Identity number 3. Let's take a peek at our formula sheet. Look at almost 1/2 of our formula sheet is all trig. Look at this. It's a lot. Well, we're going to definitely keep this in front of us when we're working on trig and these trig identities. So look at what we've already discovered. Here is our 3 trig identities that we've seen so far. We've got sine squared plus cos squared is equal to 1, and the other 2 that we just derived. There it is. Okay, now that we've got these 3 basic identities, and we also have our quotient and reciprocal identities right here, which we knew from before from our unit circle, let's do a couple questions. All right, what do we need to be able to do with these identities? In this unit, we really need to be able to do 3 things. We need to simplify, we need to verify, and we need to prove identities. In this lesson, we're going to do the first 2. We'll leave proving until the next lesson. All right, let's try one of these. Simplify. Let's simplify cotangent x divided by cosecant x cos x and state all non-permissible values. All right, simplification. Like I was saying earlier, this is a little bit of a puzzle when we're working with identities. We don't really have an end goal in the question like this. I don't have a target. All I need to know is that I have to do some simplification here. It's a little easier when it's multiple choice and I can see where I'm heading. But for now, let's just play around with this thing. One of the common things to try is I'm more used to working with cosines and sines. So one of the things that I like to try is when I'm trying to simplify is let's turn everything into coses and sines. Now, this isn't always the quickest or most efficient. What's going to happen sometimes is you're going to do a bunch of work and say, no, not getting anywhere, and you're just going to have to try again. But this is usually a good method to try. So I turned everything into coses and sines, and I'm going to start doing a little bit more simplification. Well, down in my denominator, I see that I can simplify this. Remember, when we're multiplying fractions, numerator with numerator, denominator with denominator. Well, hey, as soon as I see that, I know I've been doing this right. Cos x over sine x divided by cos x over sine x. Well, that's 1. Hey, that's a great simplification. They're not always going to simplify down to a numeric value, but if it does, you got to feel like you're doing this correctly. There's part A done. The other part of this question said, state all non-permissible values. Well, where is this function undefined? Well, I definitely need to look here because I need to be worried about division by 0, but I'm also going to look here, right? Because cotangent's cos over sine. So cotangent's also not defined for sine x not being equal to 0. So maybe I'll just look at this line here. It's a little easier for me to see. So my non-permissible values, I need to say, well, that's where sine x can't be 0, and where cos x can't be 0, and this guy here is sine x can't be 0, but I've already got that. Okay, well, where can't sine x be 0? So sine is 0 at 0 radians, pi radians, 2 pi radians. Cos x, well, cos can't be 0 at pi half, 3 pi half. Now, it says all NPVs. I found all the NPVs from 0 to 2 pi rads. However, it says all. I can keep going. This is almost like a coterminal angle question. I need a general formula here. So all coterminal angles, I'm going to combine these two together. Combine together, well, x can't equal. I'm going to start at my first angle I have, 0 radians, plus I notice the distance between all of my non-permissible values is pi half. So pi half n, a member of the integers. And now, do I really need that 0 there? No. I don't mind it. It doesn't bother me. But most people wouldn't write it that way, I don't think. And there's the formula for all of my non-permissible values. So when I get this on a quiz or a test, I have to find all of them. It's like I'm writing a general solution. Okay, there's simplifying. There's finding a non-permissible value. There's part 1 done. All right, let's take a look at the last thing we need to cover. We're going to verify. So what verifying means is we're showing an identity is true for one value. This value, pi 6 radians. The difference between verifying and proving in the next lesson, we're going to show that this identity is true for all permissible values. So when we're doing this, here's what we're going to do. We're going to work with the left-hand side and the right-hand side separately. So the left-hand side, cotangent squared x plus 1. We're going to use this value of pi over 6. So I'm going to sub that in. Cotangent squared pi over 6 plus 1. Now, I'm going to use exact values here because this is my unit circle. So pi over 6. Well, if I think of my unit circle, here's pi over 6. That's root 3 over 2 and a half. So what's the value of cotangent pi over 6? Well, that would be x over y. Well, that's going to be root 3. So this is root 3 squared plus 1, 3 plus 1, 4. There's our left-hand side. Now I go and attack the right-hand side. The right-hand side is cosecant squared x. Sub in my value, cosecant squared pi over 6. Okay, well, cosecant squared, that's 1 over sine. Well, 1 over sine is my y value, so 2 squared, which is 4. Guess what? We just verified that the left-hand side equals the right-hand side. So we verified 4 pi over 6 radians. This is an identity. We haven't proved that this is true for all values. There's the big difference between a proof and a verification. Now, to end off, what I'm going to show you is a quick little trick using our graphing calculator to figure out if something is an identity or not. So I'm going to go and I'm going to switch my mode to radians is fine. And let's graph the question we just had. So clear out everything we have. In y1, I'm going to put the left-hand side of the equation. Now, it was cotangent squared. We don't have a cotangent button. So what I'm going to do is I'm going to be very careful here with how I'm about to do this. If you have this fraction button, this is where you want to use it, okay? Cotangent is cos x over sine x, and I'm going to close my parentheses, and now I square the outside. Cos squared over sine squared plus 1. Bingo. In y2, it's cosecant squared. Well, I don't have a cosecant squared button. I know cosecant is 1 over sine, so 1 over sine x, close parentheses, square it. And the other thing I'm going to do is I'm going to move my cursor all the way over to the left. And I'm just going to slowly get there. And you see that's blinking. I'm going to hit my enter key until it becomes a thicker line, so I can tell the difference between these two graphs. And now what I'm going to do is I'm just going to go back up there. I noticed this one. It looks like I lost a set of parentheses there, which bothers me. Right here. That looks better to me. Okay. Changed it back. Okay, maybe my calculator is doing something interesting here. Okay, let's hit graph. Let's go zoom trig. If the graph is the same, it's an identity. If the graph is not the same, it is not an identity. Well, look at that. There goes the dark line. And I just showed it's an identity. There it is. So there's a visual way to show that this thing works. Okay, friends, there's verifying, there's finding non-permissible values, and there's simplifying. In the next lesson, proving.